All right. So let me just, we'll start, so we talked a little bit about two-way tables and things like that, and we're going to look at a few things and just get a taste of maybe the ideas behind statistical reasoning, okay? And at this point, this is just a mere taste, and we're not going to get really into it, but just to get us thinking about statistics, and be sure you do your reading, because I'm going to kind of go through this part relatively quickly in terms of there's a lot of definitions and stuff covered in the book that it is important for you to know, but I'm not going to spend too much time in class going over. Yes?
Are we tested on the definitions on the exams?
Yes, it's not like a vocabulary test.
That's what I was wondering.
But probably harder than vocabulary test, I guess. I'll ask you, like, I don't know, present some kind of scenario, and I'll ask you which word does this scenario apply to, or something like that. Okay, so yeah, it's not like you've got to write out the definition word for word or something like that. But you do need to understand the concept. Okay, so let's talk a little bit here, and let's say all right, let's see. Let's say we looked at people's health, something about their health, and maybe some kind of condition that they have.
Eyesight.
Okay. So let's just do something simple, and let's say okay. So we will say so some people suffer I don't know, suffer from headaches. Okay. We'll say migraine headaches. Okay. And so we'll say like people frequent migraine headaches. Frequent migraines, and then versus infrequent migraines. And let's say we look at whether the people work in an office or industrial environment. Okay, so just random things. Okay, so we got industrial workplace versus office workplace. Okay, so this is an oversimplification of life, but just for class examples, this is good enough. And okay, so let's say we looked at 100 people who are in the industrial workplace, and we looked at 120 people in office workplace. So we looked at a total of 220 people. And let's say of those in the industrial workplace, 20 of them have frequent migraines, which meant 80 did not. And then let's say in the office, 18. Okay, 18 had place, and this is so that means 102, 182, and 38. All right. So then I ask something like, I ask maybe is there is workplace and migraines related? So, is someone's workplace and the frequency of having a migraine, are those two things related or not?
Can't tell.
Well, okay, so how can we even start to answer this question?
You could say no, because there are other variables that could impact whether they have frequent or infrequent migraines.
Okay, so I mean, there's other variables that could be involved, right? But the same argument could be used for smoking and lung cancer, right? You look at people who smoke and people who don't smoke, and we see differences in the rates of lung cancer. But then the tobacco companies always say, well, there's just a bunch of other factors, so you can't just pin it on smoking. So there is some truth, but then there's also weaknesses in that. So that
there's not a big difference, so you can't really tell if it's because of the workplace.
Okay, what difference are you pointing out?
I'm looking at the frequent migraines and the workplace. It's just 20 to 18.
20 to 18.
Yeah.
But then what if I said, let's look over here? It's 80 to 102.
Well, it's still not that much if you look at the total.
22.
Or 102 to 18 or 80 to 20? What are we looking at here?
No, you're looking at
Yeah, okay, so we don't look
workplace.
only at the
Yeah.
columns. Okay, so let's, well, alright, so.
But frequent is already.
Okay, so what percentages do we want to look at? What percentages? So, okay, so this here we've got 100 people in the industrial workforce and 120 in the office workforce. So they're not exactly the same numbers. So maybe we should look at percentages, and what percentages do we even want to compare?
20 over 100, 18 over 120.
Okay, so we'll say, you know, what percent of industrial workers, industrial employees have frequent migraines? And the answer to that was 20 over 100, which gives us 20%. Okay. And over here, we looked at, you know, what percent of office workers have frequent migraines. And the answer to that is 18 over 120, 15%. Okay? Alright, so now we've got 20% versus 15%. What do we say with that?
We could say it's probable that industrial.
Maybe, okay, alright, so does this mean that industrial employees have more at a higher risk for frequent migraines than office workers?
Of 100 people that they tested.
Okay, so we looked at 220 people, alright, 100 of them were industrial employees and 120 were office employees. Okay, so you guys are asking the right questions and you guys have the right amount of skepticism, okay? And yeah, so we've got 20% versus 15%, okay? So in the data that we looked at, in the 220 people that we looked at, yes, okay? Of the 220 people, the industrial employees, more of them had migraines than the office employees, okay? The question is, based on these results, 20% versus 15%, can we say anything about industrial employees in general and office employees in general? No. Yes, no, okay. So some of you guys are saying no, and my answer is it depends. It depends, okay? Depending, we're going to, later on in this class, learn how to do statistical analysis, and sometimes the conclusions from the data can be expanded onto the rest industrial employees in general and office employees in general, and other times it's not. And we're going to talk about an idea of statistical significance, okay? Meaning here we've got 20% and here we've got 15%, a difference of 5%. And we're going to ask, is 5% statistically significant or not, okay? And the idea behind that is, if I were to take another sample of 220 different people, okay? Let's say I get just another 100 random people who work in the industrial areas, and another 120 people who work in offices. I'm probably not going to get exactly the same numbers here. I'm not going to get 20 and 80, 18 and 102. I'll probably get something similar, but different, okay? Maybe I get 18 and 82, okay? And maybe I get 20 and 100 or something, okay? But maybe the numbers are different. We're going to learn about whether that 5% difference, is that something that is rare and only happens when we only in our data set, or is that something that could just happen on a regular basis whenever I take 220 different people, another survey of different people, okay? But we've taken the correct first step in looking at 15% versus 20%, okay? This is a good first step, and then the question is this difference, this 5% difference, 5 percentage point difference, is that important or is it not important, right? And people debate over this all the time, right? Global warming, and they're saying, you know what, temperatures have been rising, okay? You look at the data, it's true, temperatures have been rising, okay? And the question is, well, is this a significant difference or is it not? Does it matter that temperatures went up 3 degrees over the past few years, or is that bound to happen anyway, okay? Does it matter that what people are doing, or is this just something that the Earth is going to be doing anyway, okay? And you've got people, statisticians on both sides arguing this is a big difference, this is not a big difference, okay? And we're not going to settle the global warming debate in this class, but we'll at least learn some of the tools that people use to help answer these types of questions, okay? And so yeah, some of you guys are skeptical, and I would probably say this 5% difference is probably not significant at this point, okay? But sometimes you get a smaller difference, maybe of 1% or 2%, and it turns out that 2% difference is actually significant, okay?
How do you do about that 5% is not significant? Wouldn't you have to do like a whole new sample?
So we'll, ideally we could. Ideally we would have lots of money to do research, and we can just ask all the people and things like that, okay? The truth is we can't. And sometimes we get a sample of 220 and we have to make conclusions on our sample of 220. And so, and the answer is we can make conclusions even off a sample of 220, 15, 20% without the need to do more sampling, okay? And we'll
But to determine the margin of error, you have to do more than one sample, right?
No. You can figure out a margin of error based off of one sample and things like that. We'll see things, okay? Okay, so just another idea. Okay, so let's say someone claims that he's got a coin that is it's a trick coin, all right? And he says this trick coin is going to land heads more often than tails. Okay. So. Okay, this is the claim. All right. Okay, so he flips it. He flips a coin 3 times, and he gets 2 heads and 1 tails. So he goes 2 out of 3 is 67%. There's your proof that my coin truly is a trick coin. Do you buy that?
No.
No, nobody buys that. You're just like, you're stupid. Okay. I am not convinced. Okay. Why?
Number of flips.
Okay, so we only flipped it 3 times or something, okay? But 67%, that's a lot bigger than 50%, right? Okay. All right. But then what if he flipped it 1,000 times? And we get 590 heads and 410 tails. Now what?
Well, 59%. I don't know.
So we get 59%. 1,000 coin flips. What do we feel? He's legit? This coin is for real?
Yeah. Well, it could be.
Could be.
Not yet.
Not yet? We're not convinced? I would say this is pretty convincing.
Oh, really?
I would say. Alright.
But if you conduct it like a trial, and that happens, I mean, it's a possibility that could happen.
Oh, you see? Okay, alright, so
Depends on how you
this
start.
is where we get into, this is, okay, so why are we saying this is 59%? Maybe, maybe not, okay? So one argument, okay, and this, I like this thinking. What's your name?
Blake?
Blake. Okay, so Blake says it could happen. And what do you mean by that?
Well, I mean, a certain event where, you know, there could possibly be, you know, 59% chance of, you know.
I'm going to make up words for you.
Okay.
All right?
All right,
and
sure.
I think what Blake is saying is that if we had taken a regular, perfectly fair coin,
Yes.
a not trick coin, and I flipped it 1,000 times, there's a chance that I would get 590 heads and 410 tails. Anyway, with a regular old coin. Is that what you're saying?
Took the word right
Take
out
the
of
word,
it.
yeah. That's what I thought, you know? I'm glad we're on the same wavelength there. Okay. So, and this is, one argument against the trick coin. Right, so he's selling it, he's like, oh, with this trick coin you can scam all these people and you can make $1 million, right? And then, but then the person you get, this business partner says, well, I don't know, because if I took a regular coin, I might get 590 heads and 410 tails anyway. Okay, so if I took so that's one argument, all right? And to understand this, we're going to have to learn probability, okay? And probability is going to be everybody's least favorite chapter in the course, but this is one of the things, because we've got to understand the probability. What is the probability of getting 590 heads, 410 tails with a regular old coin?
50%.
It's not going to be 50%, okay? It's going to be a lot smaller, okay? And so we would have to figure that out, okay? So we learn probability for this. Okay, so this is just maybe just a little sample of where we're headed in this class, okay? And I probably spent too much time talking about this, and I've got to hurry up about the other sections on describing data here, okay? But this is just kind of an idea of where we're heading, and so. And part of all of this is our understanding of variation, okay? And we'll talk more about that. But, and I'll probably use this example again. But if somebody says, oh, you know what, you guys know where Palmdale is, right? So, Palmdale, Mojave Desert, okay? Someone says, you know, I was up in Palmdale the other day, and it was 100 degrees. So miserable, okay? And you'd say, oh yeah, well that's Palmdale, okay? And nobody would make like a news story and say 100 degrees in Palmdale, okay? Breaking news: Palmdale reaches 100 degrees. That would not happen, okay? But on the other hand, if we were in Santa Monica and it hit 100 degrees, that would be breaking news. Breaking news: 100 degrees in Santa Monica. Okay. Why would that be breaking news? Because it never reaches 100 degrees in Santa Monica, or it shouldn't. Okay. And on the other hand, but they say, oh, you know what? We were in Palmdale, and it reached 30 degrees. Okay. Again, it would not be a breaking news story. Okay, 30 degrees. That's below freezing, and it's really cold, but it would not be breaking news. But Santa Monica, if it reached 30 degrees in Santa Monica, breaking news. Okay. So why do we have like this double standard, right? Palmdale, 100 degrees, not a big deal. Okay, Santa Monica, you'd say that's too hot. And then Palmdale, 30 degrees, not a big deal. You say Santa Monica, 30 degrees, that's too cold, okay? Why? Okay, part of it is variation. In Palmdale, the temperatures vary a lot, okay? It's really cold, and at night it gets really hot during the day or whatever. It's like the surface of Mercury or something. And Santa Monica, the temperature is a lot more mellow, okay? It's a big deal when it goes below 50 degrees or something, okay? So it's a lot more mellow. You've got this nice temperatures all around. So that's an idea of variation, okay? And we're going to learn about. We have to understand the variation within a certain range of data in order to make decisions as should this be breaking news or not? Okay, is this interesting or is this not interesting? Okay. But anyway, all right. So we've got to learn about describing some data and visualizing things. Okay. So first, we're going to talk about numeric data. So this is moving on into chapter 2, numeric data, describing and visualizing. Okay. And one of the, I guess, downsides of this format of class where we're meeting once a week for 3 hours is that at this point your brains are tired and a lot of what I'm saying does not settle in. And so it's important that through the upcoming week, you look at your homework and book more than just once, okay? Don't wait till next Tuesday and do all of your homework on Tuesday, okay? You're not going to learn statistics that way. Okay, at least 3 or 4 times this week. So tomorrow, look at it, okay, the next day, or you can give yourself a day rest, but look at it multiple times throughout the week and absorb a little bit at a time. Your brain will do much better. You'll learn more that way than trying to do it all at once. Okay. So describing and visualizing numeric data. Okay. So one tool is the dot plot. Okay. And with a dot plot, you've got the axis, the horizontal axis, and this will form a scale. And we're going to draw dots for each value that we have. Okay, so maybe I look at. Okay, let's just look at. We can only do one variable at a time right now. Okay, so we'll just look at the weights of people, and maybe one person was 120, 130, 145, 105. Okay. If I made a dot plot for this data, okay, we need to form a scale. So 10, 120, 30, 140, 160. Okay, and then I would draw a dot for each data point. So I would draw a dot at 120, a dot at 130, a dot at 145, and a dot at 105. Okay. Now this is very uninteresting because there's only 4 data points. Okay, but you can imagine if I collected a whole bunch of weights from a whole bunch of people. Okay. The dot plot might take a little bit more shape. Okay, and I would stack up the dots. Okay, and maybe the dot plot would look something like this. Okay.
Bell-shaped curve.
This is not really a bell-shaped curve, but some things might form a bell-shaped curve. Okay, but this is a dot plot. All right, and this would represent however many people I have would be however many dots I have. So here I've got whatever 25 people represented in this dot plot. Okay, and if this was weights, and let's say these were just to make things simpler. Let's say these were the weights of women. Okay, female weights. Just because if we looked at male and females, it'd just be we'd have a lot bigger spread. So let's just say female weights. What do you think this number around here would be? If I were to put this scale.
118.
Okay, so that's very kind. Probably not 118, but maybe 130 something. Okay, I'm not trying to. I don't want to get in trouble or anything. Okay, down here would probably be around 100, maybe a little bit lower than that. Okay. Okay, and then so that means one. Oh gosh. All right. So this is according our scale, and so this just shows us that a lot of people, are in the 100 to 160 range, and we've got some people between 160 and 190. And then, the further we go out, the higher and higher we go up. There's less and less, but there are people who weigh, over 200 pounds, and that's, people are just different, built differently, and that's life. Okay, we celebrate the variation.
You should have really chosen.
I should have picked a different example. You're right, and I regret my decision immediately. Okay, this is the example that we've gone with, and this is that. Okay, but yeah, okay. So, but this brings up a few points here. Okay, I could. Rather than having dots, okay, we could summarize this just kind of with a curve that would look kind of like this, okay? All right, and so the dots are a little bit distracting, but I could just say the curve looks something like this, okay? Is that all right? This tells us about the shape of the distribution, okay? All right, and I forgot your name already. Kurt. Kurt was saying something about a bell-shaped curve, okay? This is not quite a bell-shaped curve because a bell-shaped curve is symmetric. Over here, it's not symmetric. It's what we call skewed, okay? And this is technically right skewed. And what I mean by that is that we've got this tail going off in this direction, okay? And if you have trouble remembering, if you were going to use this as a weapon, this shape as a weapon, which side would you use to stab or skewer someone? the right side. Okay, so you can remember that. I'm not trying to be violent, but just it's a mnemonic. It will help you remember. You'll all remember that this is right skewed. Okay, but what does it mean to be right skewed? Okay, what it means, if we're looking at the weights of people, is that where would you say the average or the middle would be? 130-ish, 140-ish, something around here, okay? To be right skewed means we've got measurements or people who are far to the right, but no one far to the left, okay? And that makes sense, okay? Because if the average, let's say, just for argument's sake, the average is 140, okay? There are people, who weigh maybe 220, okay? 220 pounds, which is 80 pounds above average, okay? On the other hand, to go 80 pounds below average, 140 minus 80, would take us down to 60, okay? And there shouldn't be anyone, 60 pounds or something like that, okay? But there might. So this just shows that there are people in this direction, but none in this direction. Okay? And actually, once you go beyond like 300 or something, to go as far the opposite direction, you'd be in the negative zone. Impossible. Okay. So you've got right skewed, and on the other hand, you've got, what would this be called? Left skewed. Good. Okay. And this would be just the opposite, where you've got a lot of people down on, not a lot, but some people who exist down in this range. Most people are in this zone, and nobody over a certain thing. Okay. So this might be something like test scores. Okay. You can't get over, 110% or whatever. The maximum score, 100-something%. Okay. Most people will be between 70, 60, and 90 or something. But yeah, there will be some people on the low end, far below average or something, and that would be left skewed. Okay, so that kind of thing exists. And then if we're not talking about skew, this would be symmetric. Okay, and this is something like height, the heights of people. Okay, so if we're talking about men in the United States, the average height is around 5'9", 5'10". Okay, and so I'll just write 5'9", and you can go above average and below average. The farther you are away from average, the fewer and fewer people there are, but you have about the same number of people who are, a foot above average as you do a foot below average. Okay, so this is what this represents is, the height represents the frequency or how often you see. So meaning when at the top of the curve, this means there's a lot of people there. When the curve is down here, it means there's few people in this zone and few people in this zone. So if we're talking about 9 inches above average, that would be someone who's 6'6", or 9 inches below average, that would be someone who's 5 feet. Okay, you would have about the same number of people who are, when we're talking about men, you would have about the same number of people who are about 5 feet as you would about someone who's 6'6". Okay, you'd have the same number, approximately the same number of people who are 6 feet as you do who are 5'6". Okay? That's what symmetric means. Okay, so I know I'm not writing a lot of these words, but I hope the concepts are okay there. Okay. Sometimes rather than showing all of the dots, individual dots, we create something called a histogram. And a histogram, instead of, so with the dot plot you had dots going like this. whatever it was. Okay, with a histogram, you've got bars instead. So this would be a dot plot. And this would be a histogram. Okay. Now, when we create histograms, a lot of times we've got to create this bar is kind of like the dot plot, except the bar represents a certain range of numbers. Okay, so we're taking a numeric variable, and we're almost creating categories within this numeric variable. Okay, so we're saying, you know, if we were looking at the weights of people, we would create what we call bins, and you see people categorize this way all the time. But you'd say, okay, we put everybody who's 100 to 109 pounds in this bin. Everybody who's 110 to 119. Everyone who's 120 to 129, and 130 to 139. You know, all the way up to you know, the full range of people. Okay, and maybe you have one person in here, and two, and then 4, and 6, or and then 4, and 140 to 139, or whatever. Okay, this is the count, and this represents, you know, how many people were in this range of weight. Okay, and so it's like we're creating categories with this. And then once we get this, then we produce the histogram based on this. Okay, and so there's if you choose to make different bins or size your bins differently, your histogram might look very, very different. Okay, and you'll see examples of this in the book, where you've got sometimes the bins are too wide, sometimes the bins are too small. Right? I could create a bin that just goes from 100 to 200, and then or 100 to 199, and then 200 to 299, and you would lose a lot of information, right? You'd just have this giant bin that contains almost everyone, and then a couple small bins that contain a few other people. Or on the other hand, if I made a bin for every 2 pounds, right? 100 to 101, 102 to 103, 104 to 105, okay? You would have, the bins would be too small, and you probably would have very few people in bins like the 103 to 104 and things like that, because most people round their weights up to the nearest 5 pounds or something like that. Okay, so that's those are histograms. The book will talk about stem plots, okay, and there might be a homework exercise on stem plots. I think it's simple enough where I can not do it in lecture, and you will pick up on it if you do your reading, and if you're totally stuck to do your homework problems related to it, you can watch the video. Okay, so this is another thing. If you get stuck during the homework problem, I strongly recommend that you go through the book and try to figure it out on your own. But if you can't, you can take a peek at the video, but don't just watch the whole video through, okay? Start the video, see if your question is answered, and as soon as the part that's giving you trouble is answered, pause the video and then try the problem out. It requires a lot of self-control and self-discipline, okay? But I urge you to do things that way, okay? So you guys, yeah, you'll have some problems in the homework. The reading will definitely help out, so be sure you do your reading and then work through those problems. And if you guys have questions, I urge you to put your questions on the Facebook group, and I'll answer them there. Okay? So we'll see you guys next week, and good luck.